Hi guys, today we're going to do a lesson on weird things in the universe. So we have three awesome topics which you've probably never heard about. We have the dark night, we have strange matter, we have dark matter, super weird things in the universe. So let's talk about the dark night first. Well, what is it? Well, it's an exoplanet. An exoplanet is a planet that's not in the solar system. So it could be in a different solar system, like 100,000 light years away. And why is it called the Dark Knight? Well, because it on Earth, sodium, titanium, and sulfur sometimes are solid, and in this planet, it's so close to its star that these become vaporous. That's how hot it is. It becomes vaporous. There's vaporous sodium, possibly even titanium oxide, and vaporous sulfur. And it has an odd atmosphere because it's called the Dark Knight because of its odd atmosphere. Why? Is it called the Dark Knight? Because its atmosphere, the sodium, the titanium oxide, absorbs the light and prevents bright clouds from forming. So it's called the Dark Knight because it's darker than virtually anything you're gonna see in your life, ever. Okay, the next thing is strange matter. Okay, what is it? Well, it is a strange form of matter, literally, that it's very dense, it's super dense, and it's very stable form of quark matter. It's quark matter. And it is, in theory, what would happen if it collided or interacted with regular matter? Well, let's just call it strangelets. There's a block of iron, okay? Here's a block of iron. There are two different types of strangelets. There's positive and there's negative type. Well, here comes a positive type. Here's block of iron. Okay, it comes, right? It hits block of iron. Okay, maybe a little atom collision. Yeah, maybe it passes. Maybe it collides with an atom, releases a little photon, something, right? Okay, great. Now, let's take the negative type. Negative type is the more dangerous type. This is the type that you want to worry about. The negative type comes, and it is a stable type that when it hits atom, it rips apart the protons and neutrons inside and it destabilizes them and rearranges them into strange matter, which turns in more, and eventually this iron block is no longer an iron block. It is a strange iron block. And it will release a lot more strangelets, which are strange quarks. And these strangelets will come and hit the house, and the house will, once a little bit of the house comes, it explodes, releasing hundreds of thousands of millions something strangelets. And it only can form in very hot, very dense, very intense heat, a lot of pressure. In fact, pressure matters. If it's a little pressure but it's so much heat, it's still not going to form. It has to be pressure, heat, and density. Those three is what matters. That's the ingredients. And where can you find those three ingredients? Probably in a neutron star. Very dense, very hot, and a lot of pressure. So sometimes sometimes the neutrons are gonna, because it's quark, it's so compressed, sometimes it's so compressed that the neutrons are no longer gonna be separate, and it's just gonna be quark. It's gonna be up quarks, 2 down quarks. So it's every 10 up quarks, there's 20 down quarks. So there's too much down quarks. So sometimes the down quark, there are 2 down quarks, one of them will become a strange quark. And together, a up, down, and a strange quark will become a strangelet. It's just like a neutron. It's just like a neutron, except it's strange. And it is a virus in space. You know why? Because it can spread throughout the universe. Sometimes when neutrons collide in a kilonova, it gets released, and maybe a little hits a planet becomes strange. Releases, maybe there's star orbiting the star, boom, the star becomes strange. And it's a virus throughout the universe, and it could spread. But it's only theoretical, because we can't observe inside a neutron star, right? We can't observe strangelets, right? So this is theoretical. So only if you actually go inside a neutron star and check, you're probably gonna find out the truth, but we don't know. This is theoretical. So that's what would happen in theory about strangeness. So the third topic is dark matter. What is it? Well, it's theoretical matter, because the reason why we know it's there, Do you know how we know it? It's there because sometimes we see galaxies spinning way too fast. We see a galaxy, right? Planets, stars getting flung far out. We see galaxies, the universe is expanding, galaxies moving, and then all of a sudden they're pulled towards a region. A lot of galaxies pulled towards a region, an invisible matter. So that's how we know it's there. Do you know why? Because of its gravity. But we don't know anything else. But we do know that it's more than 80% of the matter in the universe. More than 80%. That's a lot of matter. So it must be, they're very big clumps. And those clumps probably formed in the beginning of the universe, where when it doesn't interact, the heat stopped particles from forming. But dark matter, it didn't interact with, the heat didn't matter at all. Cold, hot, it doesn't matter. The dark matter clumped together, and eventually when the universe cooled down a little bit, the particles formed, and the gravity of the dark matter pulled in like gas and hydrogen and helium and all that, and it got clumps and stars formed and then galaxies. So we think that without dark matter there would be no universe at all, and just hydrogen gas and helium gas floating around, and there would probably be no us. Now we know that the universe would not make sense without it, because the galaxy is spinning too fast. The reason why the stars aren't flung out because of the galaxy spinning too fast, because dark matter is there. The extra matter is adding gravity, so the stars are spinning fast, but they're still not getting flung out because of the gravity. But without dark matter, it will probably get flung out, right? Same thing with the clumps. Without dark matter, the galaxies would just go, right? And sometimes the galaxies are colliding because of dark matter. There's a clump of dark matter and there's a galaxy here, a galaxy there. The dark matter gravity pulls them in and they collide, forming a bigger galaxy. We also know it does not interact with light. We know it does not absorb, it does not emit, or it does not reflect light. It basically doesn't, it does not interact with light at all. It does not interact with light at all. So, and it's different than regular matter because we don't know what it is. We know it's theory. It's a theoretical, so we don't really know what it is. All we know that it should be there, and without it, the universe would not make sense. It wouldn't. It just wouldn't. And I think that's it for today, guys. Thanks for watching. Bye.